Okay, good. I'm back and I will start record. Okay, great. I think I can start. Okay, so good afternoon, everybody. I'm very happy today to have with us Hugo Confraria. Hugo is a research fellow at the Science Policy Research Unit at the University of Sussex, and is a postdoc at the School of Economics and Management at the University of Lisbon. Hugo is involved in a very interesting project about science, technology, and innovation, and the Sustainable Development Goals. So I think it's going to be a very interesting presentation, and I just leave the floor to you, Hugo. Thank you very much for being here.
Okay, thank you, Roberto, for the nice introduction. It is a pleasure for me to present indeed some of the results of the strings project that I'm working with some colleagues at SPRU. I will start. So this presentation has mainly two objectives. So first one, present these initial results about this project, and then I think also give some ideas, because these are master students, about how also a research project like this works, some of the methods used, some of the research questions that we are trying to ask, and so on. So I will start to talk a bit about the strings project, and then move to two basically work packages. One related with the literature review that we have done about the relation between STI and the SDGs, and then some quantitative analysis. So in this research project, our main objective is to try to improve our understanding on how science, technology, and innovation contributes or not to meeting the Sustainable Development Goals. We want to produce some kind of mapping of how different areas of science, technology, innovation positively or negatively affect the Sustainable Development Goals, and provide the decision makers, policy makers, academics with evidence and tools to help align STI with the SDGs. This is an ongoing project. We are close to the end, but a full report will be published in November 2021 with the United Nations UNDP development program. And yeah, this involves a number of colleagues also from UCS, UCL, University College of London, CWTS, University of Buenos Aires, many colleagues in different places in the world. So a summary of the approach and the methods that we are using is here in this slide. So basically, we are trying to do systematic data analysis to map and visualize research and innovation activities across countries, which are related to the Sustainable Development Goals. We have case studies in India, Kenya, and Argentina. I will not address that in this talk. We are now starting to engage with a diverse range of international experts to a survey that, at the end, if time allows, I would like to get your inputs on. And then we have other work to develop related to the development of policy pathways to align investments in STI to contribute to the SDGs. So, as I mentioned in this presentation, I will try to set the stage. What are we talking when we talk about science, technology, innovation? What we're talking about? What are the SDGs for those that are not so familiar with these United Nations goals, global goals? Then I will say the main results from the literature review that we did, do some attempt to map countries' research priorities in relation to the Sustainable Development Goals. And if time allows, I will let you work on this survey that we are sending to a lot of different experts in the world. So to kick off, I think it's important to acknowledge that when we are talking about the relation between STI and the SDGs, we are talking about the interaction between two very broad, complex systems. So science, technology, and innovation, each of these sections have different incentives and governance mechanisms. So you can think about policies to stimulate science. You can think about PhD scholarships. You can think about certain programs to incentivize certain research themes instead of others. You can think about different things to incentivize research on a certain direction. But you can also think about technology policy or innovation policy, for example, as diverse as, for example, patent boxes. So incentives for R&D related to intellectual property rights in certain countries instead of others. So within STI, there is a plethora of things that you can think about. And if you move to okay, so and even within STI, so there are different things within science, technology, innovation. Even different countries have different power structures and different incentives even within a country. So different regions may have different priorities. The priorities of a country like the USA are completely different from a country like Mozambique, for example. So things are not clear-cut about what STI investments should we prioritize. And then if we move to the SDGs, there are 17 SDGs. They are about all sorts of challenges, and there are complex interactions. So if you solve some problem related to hunger, you will solve probably a problem related to poverty. If you solve, for example, if you improve economic activity, for example, for more fisheries, you may destroy the habitat of fish, and then you improve one SDG and you create a challenge in another SDG. So there are these complex interactions between SDGs, synergies and trade-offs. And if you combine the challenges that exist within each SDG, the responses that you can have related to STI, and the perspectives that different actors may have about it, and the interactions, you have millions of directions that this can go. So this is indeed a very complex relationship. And yeah, so it's important to have that in mind, about this complexity. So if we go into detail, and I would like to say something about the SDGs in particular. The SDGs are 17 goals, as I said. They include 169 targets, 232 indicators. So these were debated within the UN with different stakeholders. And it's important to understand that within a certain SDG, there are different priorities, but also that they tried to make them to understand progress within each SDG. They created a set of indicators that you can at least try to capture how things are evolving in some SDGs and not in others, and so on. So I'll give some examples for those that are not so familiar with these SDGs. One is related to SDG 3, good health and well-being. So here we can see, so these pictures come from the Global Sustainable Development Report, the latest, and they have a set of indicators. And within these indicators, they create a number of figures to see how things are evolving. So, and the main message from this figure is that, so this was already in 2020, so after the COVID situation started. So they are arguing that, for example, here, the COVID implications is that there were healthcare disruptions, reverse decades of improvements, for example, in the neonatal mortality, and for example, in communicable diseases that are highly problematic in countries, in African countries, sub-Saharan African countries. So the shift in priorities from rich countries to solve their own issues creates a huge or some problems in terms of solving the issues related to malaria in these countries. So the pandemic has changed a lot the priorities and the problems that were being solved in some areas related to health. We have going to another SDG. So for example, climate action. We know that the Earth is getting warmer, and this is mostly because of CO2 emissions. So here, what they argue, and this I think it's a very interesting finding, is that resulting from COVID, actually we had a reduction in CO2 emissions in 2020 of 6%. So all the collapse in economic system and all the things that stopped reduced the emissions in CO2 emissions 6%, which is good, and is kind of a line. It's still short, they argue, about the annual reduction required for the limit that was agreed by many countries. But imagine, so in order to be in line with the objectives that are needed to avoid global warming, we need kind of a COVID crisis every year or worst to stop emissions. So this is a real issue. But again, my point here is that in my opinion, these SDGs are really good because they have indicators that you can track progress. So if just another one, and this is the last one that I will show. So related with life on land. So they argue that the world is falling short on 2020 targets in terms of biodiversity loss. Over 31,000 species are threatened with extinction. Many have been extinct in the last years. There is also the COVID implications. It is not sure if this is the causal mechanism, but they argue that COVID maybe emerged because of human beings going to ecosystems where there were indigenous species with their diseases, and this interaction between humans and wild animals may increase the probability of us having more of these diseases like COVID. So the main point here is that there are a number of indicators that we can track progress, and these are related to targets that were agreed by all countries. I just wanted to give a general overview of some of the issues that are within these SDGs. So these SDGs are not just life on land or simply message, they are full of targets, full of indicators. So what we did in this literature review, and please, if you have a question, a clarification question, please stop me at any time. Here, our objective was to collate, summarize, and analyze the main findings from publications, both scientific articles and gray literature, that look at this complex relationship between science, technology, innovation, and the SDGs. So we end up grouping all relevant literature that we find in 4 different categories that we classified as identification of misalignments between STI investments and SDG challenges, approaches, both theoretical and more practical, to shape STI to achieve SDGs, synergies and trade-offs, there is a huge literature about it, and monitoring of the success of STI for SDGs. So here in this literature, I will go into details about what we found in each one of these groups of literature. It is important to mention that our approach, we didn't look at the broad relation between science, technology, innovation, investments, and sustainable development in general. So this is very vast. So we looked specifically at publications that have the term sustainable development goals. And we also exclude publications that were very specific in terms of just looking at the contribution of a specific technology, machine learning, biotechnology, to a specific target. So we try to have broad publications that compare different STI areas with different SDGs. So our first step was to create a query, a combination of terms to identify publications, and we search both in indexing systems of with academic literature, where Science, Scopus, Yellow, and we also search what so-called gray literature. So this is policy reports, working papers, reports from government agencies, and so on. We search in Google, Dimensions, different platforms. We check all abstracts and summaries, and we classified each document to see if they were relevant. And then we discuss with colleagues. We also ask colleagues from the project to suggest publications that they found that should be interesting. And we arrive at this final selection of 62 publications that later on were grouped in these 4 different themes. So the first theme, as I said, is about the identification. We argue it's about the identification of misalignments between STI investments and SDG challenges. So a first point, and this is kind of obvious, from a global development perspective, most science, technology, innovation activities are performed in high-income countries, serving a few people and industries. So if you look at the amount of scientific research that is done by high-income countries plus China, you see that 90% of all research is done in high-income countries in China. This is a huge disparity. If you look at patents in the top 5 offices, this is US, Europe, Korea, China, and Japan, you see that 85% of all patent applications in 2018 are in this office. So there are kind of huge disparity in terms of year proxy publications and patents as innovation as STI activity in high-income countries, higher income countries. We also, there was a very interesting publication a survey that was sent to people from 34 different African countries, where the researcher asked, for you, what is the SDG that is most important for you? What should be the SDGs that government in your country, in your region, should give priority to? And then they have the demographic characteristics of the people that responded. And then they found that within regions, societal priorities differ markedly with economic status. So for people that have lower income, they found that hunger, health, water and sanitation, access to energy, infrastructure, innovation in infrastructure were very important. In contrast, for people that have higher income, they found that SDG 8, so for example, economic growth, or SDG 16, peace, justice, and strong institutions were more important. So even within a country, people have different priorities. So and we thought that this is interesting also to have found this empirically. Another potential source of misalignment between STI investments and SDG challenges is that within a certain area, in this case, the example that I'm giving here is health, you may find that there are the priorities are misaligned. And I will explain what is in this graph. So here there are different diseases, and the blue bars are the amount of research that is done related to these diseases in the world and by Big Pharma. And the red bars are the amount of people. So this is measure of disease burden, is the amount of people that die or it's impossible for them to work because of certain diseases. So, and this is for the high-income countries and for the world in general. So what I would like you to notice is that the majority of research that is done in the world is done in health, is done in cancer. So a disease that affects a lot high-income countries, but in general, in the world, it's not a very serious problem. In the world, in general, diseases that are much more problematic are infectious diseases, or in this case, cardiovascular diseases. And if you look at the amount of research that is done in these diseases, specifically in infectious diseases, you'll find that the proportion is much smaller. So here, talking about 8% of the research in the world is done in infectious diseases, and the disease burden is almost between 15 and 20%. So because rich countries have their own priorities, so in rich countries, people die a lot of cancer, the priorities of research funders go into a lot of cancer. But this is not the major problem in the world. The major problem are other types of disease. So this point is to argue that within a certain area, there are also misalignments in terms of what the research priorities are. Another point that we found that may be a source of misalignment in the literature is related to there are certain types of STI investments that may create harm in society. So a classical example that we find is, so we want to invest in energy or in clean energy to avoid fossil fuels, and you have choices. You can invest in nuclear energy, or you can invest in other renewable energy sources. And depending on how priorities are set, you may have some problems. In this case, imagine about Fukushima or other cases where in trying to search for other solutions other than fossil fuels for energy source, you end up with even worse solutions for the environment. In the UNDP report, they argue also related with recent advances in automation and artificial intelligence that 9 SDGs could be negatively impacted by this type of advances, and this can be increases in unemployment and more precarious jobs in gig economies and on-demand economies. So this is to point out that there are certain STI investments that may be harmful for society in general, and this is also a source of misalignment. Okay, so I've pointed out some sources of potential sources of misalignment identified in the literature. Now I'll talk about solutions. And in the literature, I mean, this is very vast, but in the literature there is an important concept that is related with this directionality in STI policies to focus on technological and innovation related targets on the SDGs. And this can take the form of mission-oriented approaches. And here I will give an example of what are these mission-oriented approaches. So in this picture, imagine that you have a problem that you want to solve, clean oceans. So we want to get less pollution in the oceans. And then you decide about a target. So I want a plastic-free ocean. And then you have a target that is reduction on 90% of plastics entering the marine environment and so on. So what the policymakers in this context of these mission-oriented approaches would do is to invest in a set of projects, different projects. So you have calls for different projects related with this overall goal and target that in theory, or the best way would be to combine different areas of knowledge, and by having kind of a portfolio of different projects, research and innovation projects, some might work, some might not work, you would presumably try to achieve this target. So you have a big mission, okay, we want to clean the oceans, and you set your incentives, science, technology, innovation incentives to have projects that try to solve this target. So this is a possible interpretation of the idea of mission-oriented approaches and having directionality to solve targets such as the Sustainable Development Goals. Another authors discuss that in a similar line, for example, propose to improve the orientation of STI policy towards SDGs. So similar challenges. So the European Union also has similar challenges and tries to fund these kind of projects to solve their own challenges that they decide within their own stakeholders. Another report argues from the UNCTAD that reorienting STI towards sustainable and inclusive outcomes involves changes in the priority setting process and implies connecting STI policy frameworks towards national objectives that are associated to SDGs. Some of our colleagues in Strings also have a blog that about this discussion, what directionality is. It's not so much about how much, how fast, who leads in this type of priorities, but which way, or which pathways, and why we invest in certain pathways and not others. So this is about this concept of directionality. So trying to have these objectives or challenges or goals and try to funnel your STI investments towards these challenges. So another approach that we find that in several reports relates to plans, roadmaps, or integrated assessments. And here, the idea is very much to involve key actors, civil society, universities, the plans from the governments, plans from national development plans, and so on. Involve all the stakeholders for them to decide which are, and if possible, of course, try to have also the department from government that looks at international relations and SDGs plan, and try to combine all this to have a national plan that tries to address the issues related with the SDGs. This is a vast literature. I will not go to details, but there are detailed roadmaps on about how to do it. If you want later on, I can give you the source. Different approaches look at this relation within the framework of transformation or transitions. This is much more looking at the nature of technology and its role in the wider economy, where technology ownership control lies, its existing orientation and focus, and particularly how it might be reoriented in a transformative way. So this is a concept that needs a bit more discussion, but it's related with big changes, big transformations in society that go beyond a peculiar STI changes in priorities within a government. This is more about big transformation, wide transformations. So, for example, Sachs and his colleagues propose 6 transformations. It's not clear how they are decided, but they propose 6 transformations that are needed in order to achieve the Sustainable Development Goals, namely education, gender inequality, health, well-being and demography, energy, decarbonization and sustainable industry, and so on. So they propose that there should be big transformations in society in order to achieve the Sustainable Development Goals. Other approach is related with more grassroots innovation policies, so more bottom-up, where that consider the specific situation and needs of the poor people, women and vulnerable groups. So this, it's argued, is a better way to have better solutions for the people that are most in need. Another authors or report in this case looks at or argues that the SDGs are also a potential opportunity for developing countries to leapfrog to sustainable frontier technologies. So an example that is given is that people in many developing countries with no electricity until now are adopting solar energy. And this is bypassing the use of fossil fuels and going directly to renewable energies. That is quite relevant, specifically to SDG 7, that is clean energy. The SDGs, so trying to achieve SDGs can also be an opportunity to leapfrog to frontier technologies that then, while you are working or producing or involved in global value chains about this solar panels or wind energy, you can also become more competitive and also start to produce things that are relevant within this frontier or emerging technologies, and this may be also good for your competitiveness. So yeah, this is an interesting remark also, and many authors claim for because these are very complex challenges. These global goals involve many types of knowledge. It's important to have interdisciplinary teams, multi-stakeholder partnerships, that people with different backgrounds that allow them to solve these big challenges. So another group of literature that we find relates to synergies and trade-offs between STI and the SDGs. And here the core idea is that studying the interaction between SDGs is essential for efficient design of public policies. So there might be certain investments in certain specific types of science, technology, innovation that may help to achieve a certain SDG, and by contributing to improve that goal, you might also contribute to solving other different goals. So if you find a certain kind of STI investment that helps to solve a SDG or contribute to solving a SDG that has this kind of that functions like a synergy, so helps to solve many different SDGs, probably you should prioritize those type of investments instead of investing in certain incentives that might lead to the improvement of a certain SDG, but the improvement of that SDG might create a negative impact on other SDGs. So there is a vast literature that looks at this relation, and they have several methodologies, namely correlations between time series indicators. So as I said, the SDGs have targets and indicators, and you can look at the statistical relations between them through time. So some authors do that. There are some theoretical models that study possible scenarios, as the one that I argue about. Okay, if you increase economic activity through fishing, you will destroy the habitat for fish. So maybe this is not a good solution. But the literature discussed several other cases. There are also methodologies related with expert opinions, so surveys and so on, and also text mining approaches. So looking at similarity of publication text or in publications of different publications. So this literature is quite vast. I will not go into many details. A general remark is that authors usually found that positive interactions between SDG targets outweigh the negative ones, but these interactions are greatly context dependent. So a positive interaction in one country might not work in another country. So whenever making this remark about synergies and trade-offs, one needs to understand the context that we are in. So the final group of literature that we found, that there is some research, is about monitoring of the success of STI investments for the Sustainable Development Goals. So here, as I mentioned before, we found several theoretical approaches, so several authors that try to argue how to shape STI priorities towards the Sustainable Development Goals. We found less work in trying to understand what works and how to evaluate. Of course, this is not only because people forgot about doing it, it's because it's really difficult. As I argued before, these are very complex relations and different dimensions, different incentives, so it's kind of difficult to do, but still, this is, I think, one of the major conclusions of this literature review, is that many people argue about how to do it. Very few people actually check if certain changes in policy actually deliver the objectives that were proposed. So, and related to this theme, an important issue is that many statistical systems across the globe have faced several serious challenges in tracking progress on the SDGs, which required a huge amount of data. So in this graph here, what we have is the data coverage for the different SDGs, the 17 SDGs, and the bars are the number. So the different SDGs have different indicators, and the bars are the percentage of countries that have at least one data point. So it's not across years, it's one data point for all the different indicators within that SDG. So at least, so, and these, for example, in SDG 5, that is gender equality, we have 40%. So 40% of countries, only 40% of countries have at least one data points for the different indicators that are available in the UN dataset. So this is really scarce, especially to do cross-country comparisons. And so here a crucial point is to, again, improve statistical systems in these countries if we want to capture progress in time and changes in these indicators. Yeah, mobilization of international resources and so on. Another point that we found interesting is that it's not only data collection that is missing, is also, some authors argue that the capacities about monitoring and accountability in certain countries that is lacking. And it is very important to invest in that. So some statistical offices also don't have the human capital to get this data, to put it in data sets, to share it widely and so on. So one point that we found is that more investment is needed in improving the capacities of certain countries to have policy monitoring and evaluation and getting data. And on a more positive note, it is argued that advances in technology and the proliferation of data are providing new opportunities for monitoring and tracking the progress of SDGs. So think about satellite data, think about, in this case, example, an interesting example that we found was a community of volunteers in the Philippines that are collecting household census data on poverty, nutrition, health, education, housing, disaster risk reduction, which are used to populate the information that is needed for 32 SDG indicators. So it can be about volunteer, a bit of open science, or trying to integrate people in this or communities in this process. But also there are, of course, new technologies, as I argued, satellite observation to capture specific activity. So yeah, so I think this section of the literature review, I would like to conclude by saying that yeah, we found several types of misalignments between STI investments and SDG challenges in the world. We also found many publications proposing approaches to helping shaping STI investments and policies toward the Sustainable Development Goals. We found less effort in trying to understand what works and how to evaluate the efficacy of such approaches. As I argued, this is, of course, a bit because of the complexity of the problem. As we know from the innovation studies literature, the relation between STI investments and increases in productivity is complex, non-linear, spreading space and time, and so on. I would argue that the relation between STI investments and the achievement of Sustainable Development Goals is even more complex, so even more difficult to understand. But overall, I think what we found across is that we seem to start to live maybe in a new kind of paradigm where there is a change in priorities in STI policies. We came from the linear model of innovation where you invest in science and you have technology innovation and growth, to the national systems of innovation where it's very important, the institutions, the interactions between the system and so on, to having a bigger focus on the societal needs, the major challenges of society, and how to shape STI policies to achieve those needs, those goals. So yeah, here I would like to stop a bit and ask if there is some question, and then move to the second part of my presentation that is a more that relates again with a more quantitative analysis.
Thank you very much, Ugo. Is there any question? You can write them in the chat, or you can just open your microphone and ask. Well, I do have 2 points I would like to make, and maybe there will be more questions to come. The first one is more than a question, is an observation, a consideration, I would say, which is concerning data availability. I think that there is really a key point. I mean, first of all, I was really on one side surprised, on the other side it's confirming my impression that, for instance, in terms of gender, this is an issue on which data availability is very limited, and this is really somehow limiting also the policy, the possibility to intervene with policy, because it's quite surprising, but very often countries, they do not collect information with a gender disaggregation. But more generally, in terms of data availability, I think it's quite, I mean, it's something that we probably need to think about, that I mean, data availability is a constraint for the implementation of SDGs and for monitoring the progress of SDGs. And at the other side, you have data which are now the key resource for I mean, digital companies, digital giants. So on one side, you have few companies owning a lot of data, a lot of information. On the other side, you have countries struggling because they don't have enough data. So I think that this is a kind of paradox that we need to think about. And the second point is more, this is something that maybe I'm going to send you a recent special issue I've been edited for Industrial Corporate Change about renewable energies. And I think that your point was very key. And what we find studying catching up in renewable energies is that not only the adoption of renewable energies is important, but also some emerging countries are playing a very active role in terms of producing new technologies. And China in particular is really at the forefront of, at least in some of these industries. So also the role that emerging countries can play in producing new technologies, I think, is going to have an important role. But yeah, there is a question I would like to read for you, which is this, I don't understand very much the question. The design of an asset in determining the environmental impact. Yes, how much is the weight, how much is important the design of an asset in determining the environmental impact? Something like that. So I think, I don't know exactly what an asset, what is meant for asset. Maybe Andrea Andreano would like to specify a little bit better, but I mean, I don't know if you understand the question, but I don't understand quite. I'm not sure about.
Yeah, I mean, I don't know what is an asset. If you
like to clarify. So yeah, the design of a product. So how much is important the design of a product to identify, to measure the environmental impact of the product? I think something like that.
Yeah. So regarding this question, if I can say something about it, is that yeah, of course. So for example, there is an SDG that is related to sustainable consumption and production. And of course, this SDG has some, and this is actually one of the less indicators available, but this includes issues like this one. So if the type of design of products, or if the type of setting in terms of circular economy of producing products and then making sure that they are recycled, what is the material consumption of a certain country. So these types of issues, of course, determine some kind of a country as a higher environmental impact. So yeah, of course, industries in the way that they design the products and make sure that their products are then recycled, this has environmental impact. I don't know if I addressed the question. Please, Andrea.
Yeah, I think so. Also, last week we had another a seminar about circular economy, and in fact we were talking about a lot about how for instance there are a lot of space in terms of how you design product in terms of reducing the environmental impact. I suppose that on this at the same time there are not much data available in order to measure this kind of things. So yeah. So any more question? So maybe we can move on to the second part. Yes, there is one more. Could the 2063 agenda developed for African countries be considered as a joint evolution of SDGs and STI strategies?
Yeah, I'm not sure I know this agenda very well. So
no, me too. So maybe so Guido Pampaloni knows more than us. So if you want to say something, Guido. Okay. I will check what is this agenda and maybe try to find an answer.
Yeah, but what we find is that there are several countries that try to more and more integrate their agendas, the development agendas, with the challenges and the issues raised by the UN agenda, the Sustainable Development Goals. So it is likely that this agenda developed by some African countries also includes some of the issues that were discussed here.
Yeah, I was just checking the Agenda 2063 is the agenda for Sustainable Development Goals, which was put forward by the African Union. So yeah, and we can also say that in African countries, more and more STI is at the top of the agenda of many of these countries, no? So probably a few years ago, most of the African countries were not so concerned about STI, but now it's more and more clear that STI should be part also of their agenda.
Mm-hmm. Mm-hmm. Yeah, okay, I will have a look. This is interesting and relevant. So
yeah. So would you like to go on, and then we will have a discussion at the end?
Yeah, great. Thanks. So now in this second part, we will look into a specific chapter of the report that tries to understand. So we talk about science, technology, innovation. Here we'll look about science, so research priorities in relation to the Sustainable Development Goals. This is work done together with Tommaso Charlie, that was in SPRU, but now is in Union Merit. Also, Ed Noyens and Ismail Raffles from CWTS in Leiden. So in this section, we use the Sustainable Development Goals to understand countries' revealed research priorities versus the main challenges that they face. I will explain what are these revealed research priorities. So as I argued before, this is a very complex nonlinear relation. Here, our central assumption of this study is that a misalignment between investment in research areas that are related to the Sustainable Development Goals and the socioeconomic challenges may reduce the effectiveness of investment in research to address those challenges. So if the research in a country is not done on the major problems that they have, there is some sort of potentially there is some sort of misalignment. Our objective in this section is to have an empirical, data-driven understanding of the research specialization of countries in SDG-related areas and how those research capabilities may be related with the major challenges of all countries in the world in these SDGs. So, in a nutshell, our approach is basically divided in two things. One is a way to calculate revealed research priorities in SDGs, And here we use Web of Science publication data. So this is basically indexing system that combines journals from all areas, all scientific areas in the world. It's a selection, arguably is very selective, but it is, you can also argue that it has the best journals in the world. But it is a nice data set because it has scientific research in all different areas. Our approach, I'll go later into details, but basically we look at policy reports and language. We use text mining techniques to capture language related with certain SDGs. And we use those language to look into communities of research that are related to those type of language. I will explain later on. And then we build a specialization index. So basically the revealed research priorities is if a country is more specialized in a certain SDG, let's say health, then the world average, we will consider that this country is relatively specialized in research related to health than the other countries. If it's below, if a country has less research than the world average in, let's say, clean energy, SDG 7, then it is not specialized in SDG related research. When we look at the societal challenges, here we combine all data that we could find, both in the UN database that has these indicators, these 232 indicators that I just mentioned, but we also use the SDG index. This is also the major person in this project is Jeffrey Sachs, and he uses, because of the problems of data availability, for some SDGs he uses some alternative indicators, and we basically combine these two data sets to have more the most data available possible, and that have more observations for all countries, all years. So then what we do is we normalize these indicators by each indicator. So let's imagine 0, 1, and we see which are the countries that are at the top. So what are the frontier countries in a specific indicator? We are using 80 indicators. And then we see the distance to this top, to this frontier, and the bigger the distance, the major challenge a certain country has on a certain SDG indicator. That's the core idea for indicators. Then we develop a method based on principal component analysis to combine all these distances information into each SDG. And this SDG score is like how worst is a certain country in a certain SDG. Higher values are higher distances to the frontier. And we score between -1 country at the frontier and 1 major challenge to make it comparable to the research priorities. So here I have more details about how we develop this approach to identify publications related to SDGs. We use all types of documents that we could find, and then in many cases, we select relevant text by hand. So imagine we go to the SDG report 2019, we see that there is specific text related to a certain SDG. We collect that paragraph, and we put it in the database, and each paragraph is like a block of text that later on is analyzed to extract what are the most relevant terms. And these relevant terms are terms that are not very common, but also not weird weird words. So these are what is considered by the approach like relevant terms, and they should co-occur very often in the different blocks of text that we find. And in the end, we have, imagine, a list of terms, of these relevant terms for each SDG. And we eliminate duplicates, of course, and we manually check then later on these different terms. We also discuss with our team if a term is relevant or not, and with other people, for a certain SDG, and we also combined terms for each SDG. We produced a robustness check against other approach, but then this is done by other teams also, this query approach to identify SDG related research. I think our main contribution on this regard is that, okay, we have this query of terms, these combinations of terms per SDG, that then we search publications that have these terms in their abstract or titles. But here our contribution is that we didn't use these queries to search directly for publications, is that we search use these queries to search what are the communities, what are the groups of publications that have a higher share of this text, SDG related text. So in this image here in the top right corner, what we have is kind of a map of science, of all science that is produced in the world. And the colors represent broad scientific areas like social sciences and humanities, biomedical research, life and earth science, physical sciences, maths and computer science. And so our approach is to, okay, we have a bunch of text that we know is SDG related. We go to each one of these dots, to each one of these clusters. These clusters are produced by citation relations between publications. So for example, I'm an economist, so it's very likely that I will cite later on the work of Roberta in my research, because we are economists, so we very frequently cite each other. I will not cite someone in particle physics. So using this backward and forward citations, we can create clusters of publications that group themselves according to disciplines. And what we did is that we use our queries to search in these clusters, what are the clusters that have a higher frequency of text that is related to a certain SDG or not. We argue that there are some benefits of this. I'll not go into details, quite technical, but yeah, so this is what we did. To give you an example, so we have, and this will be online very soon. So we have this map of science, so all the clusters, and based on a certain approach. So we say a community, a cluster should have minimum of 10 publications with the text that we have in our queries, and the cluster itself should have a minimum share of 5% publications with this text. And if we do this, we disappear with most of the clusters that are here in the map of science, and we end up with a specific number of communities, of clusters that are, we argue, related to SDG2 and the hunger. And this here we can see that there are a lot of communities, for example, related to food sovereignty, food insecurity, but also some things related to health, some things related with natural sciences, climate change, and so on. So these communities, and here we have some keywords that appear more often in these communities, help us understand what are the fields, the broad fields of science that are more related to this SDG. So we do this for different SDGs. So this is the case of clean energy. There are different communities more related to physical sciences, more related also to math and computer science. We have also, of course, natural sciences, but we see that the communities that are kind of activated by these different queries are different. And we had a long process to decide what were the optimal thresholds. This was again discussed within a team, and we tried different scenarios. Yeah, so later on what we end up is a number of publications per SDG that we can find using these methods. So here we have two broad thresholds, what we call thresholds, a strict and loose. So these are the thresholds that we use, but these two. But here we can see broadly that in the world, between 50% and 70% of the research that is produced in the world, we would argue that is unrelated to SDG issues. So we went to check what are the areas that don't have very little SDG related text, and these are physics, think about astrophysics, particle physics, this kind of stuff. Think about humanities and art. So for example, literature, poetry, this kind of issues. We find very little research that has the text for all SDGs identified in these communities. We find that, and this was as expected result, that the majority of SDG related research is related to health. So SDG 3 between 20 and 35%, and the SDG that has less research associated to it is poverty.
Hugo,
different.
Yeah. Sorry, Hugo, there is a question, and I also have a question. The question from the floor is, can you explain the meaning of gray literature? And also, I would like to ask you, the SDG unrelated literature. I mean, this is basically you have searched all the literature which is available in the database you have been in your database.
Mm-hmm. So gray literature is so the scientists themselves produce scientific publications, and this goes to journals, scientific journals, and so on. Gray literature is all the documents from governmental organizations, policy reports, working papers that are not indexed or do not end up in these scientific publications in journals, but are kind of not academic, but it's a category. It's gray literature. So all literature that is produced by ONGs, government institutions, even researchers that doesn't get published in journals, and this was helpful for us to identify, because a lot of the SDG jargon text is in this gray literature, in these government documents. So it was for us to extract the relevant terms, the terms when you talk about clean water and sanitation, when you talk about economic growth, what are the terms, when you talk about these SDGs, what are the terms that can be extracted from related to these SDG? About the publications. Let me see if I understand correctly. I kind of forgot. But this is the map of science. So think of it of all areas that exist that are that researchers are doing research, and because we are citing each other in different ways, you can group disciplines. You can group. So, for example, there are a lot of disciplines related to health, a lot of disciplines related to natural sciences, and so on. And this is like all science that exists. What we do is that we use these terms, this list of terms that we have, and these are huge lists. This is just an example, and we go to these communities of papers. So some of these clusters can have thousands of publications, and we use these queries, this set of terms to identify if in these, let's say, thousands of publications, their abstracts have a certain term that is associated to a certain SDG query. And the final result is, okay, we identify, as I try to argue, that there are some communities, some clusters of publications that have more language associated to a certain SDG, and then we classify these as, okay, these communities are doing work that is related to, in this case, clean energy. And we think, okay, these communities have scientific work that is related to clean energy, then all publications that are in these communities are about clean energy. So in this case, all these publications that are here are the publications from these communities. And this is how then we see the size of it, how much publications are in each communities, and so on. And that's how we calculate how much research is related to a certain SDG. I hope I have answered the question. If not, please let me know. Okay. Not sure I'm listening, but okay.
Yeah, no, it's fine. It's fine.
Fine,
Please
fine?
go.
Okay, great.
Yeah, please go.
Okay. So okay, we have identified a way to see how many publications, how much science is done that is related to all the 16 SDGs, and what is the research that is unrelated. And I think this was also the question. So the unrelated research is, so here there will be communities that none of our queries of SDG related text is identified. So these are groups of publications that our queries did not find any publication there with the text, SDG related text. And this is this huge share of research that is done, that of course particle physics and astrophysics doesn't have a text that is related to these challenges, to these problems. So that's why it's unrelated. Also text related to humanities and arts, or publications related to humanities and arts, also doesn't have language related to this text, so is SDG unrelated. So this was our approach. So before we argue that a very important question in this SDG literature is about the synergies and trade-offs. So trying to identify certain SDGs that are synergetic, if improvements in that SDG can lead to improvements in several SDGs. It's a quite complex slide, but this is our attempt to try to identify some research communities, research clusters that might have a bigger impact in several SDGs than others. So basically, so I mentioned that we have these groups of publications, these clusters, and these clusters are here. There are, I don't know, 20 or 30 clusters, and these clusters are categorized by the keywords that they have. Here, what we find is that, okay, let's say, for example, again, the different SDGs, and we try to divide. So certain countries have their authors have affiliations. SDG 3, health, is the percent of their research is related to SDG 3, health. But for example, only, let's say, 1% of the research that they do is related to poverty. And you can do this, you can see this for different country groups. So for example, in this case, low-income countries have an even higher share of the little research that they do is related to health. This is, of course, probably related with international funding schemes that fund a lot of health research in lower income contexts. But yeah, you can see that in different SDGs, there are different percentages. We also find that the interesting finding is that low-income countries produce very little SDG unrelated research. So meaning that the majority of they produce very little research, but the majority of the research that they do is SDG related, while middle-income countries, let's say, have a lot of research that is unrelated to the SDGs. An important remark here, and I've mentioned it briefly, is that 90% of the research, the SDG related research that we find, is done in high income countries and upper middle income countries. So these are percentages. This is not the amount of research that they do, is kind of the specialization that these country groups have. Yeah. So so now we are moving towards the comparison between research priorities and societal challenges of countries. And this is a more detailed explanation on how we compute these problems. I'll not go into details, just say that, again, we collect all indicators available that we have for each SDG. We create a way to normalize all these indicators, and we check for each country, each indicator, what is the distance of this country to the frontier. Then, because a certain SDG has different indicators, we combine the information of these distances into one score, one component, and then for each country, basically we have the distance to the frontier. So how problematic is a certain SDG in a certain country. And here I will reverse the order to give an example of what we are looking at as a kind of a final result. So here we have three different countries: a high-income country, United Kingdom, upper middle income country, and lower middle income country. On the top radar graphs, you have research priorities, so research specialization. You have different SDGs, and you can see if a certain country, in this case United Kingdom, is specialized in a certain SDG related research. So in this case, you can see that the UK is specialized in. First, you can see that is very specialized around the world average, but then you have a certain type of research specialization. So this is more clear maybe for the case of Argentina, that they seem to be very specialized in life on land, life below water, climate action, zero hunger. There is a lot of research related to zero hunger with agricultural productivity, with agricultural production, and this is also probably related to the economic specialization of a country, but continuing clean water and sanitation and so on. And you have this research specialization for these three countries. The bottom radar graphs, you have the problems. So I was arguing that for each country, we have the distance to the frontier of a certain SDG for a certain country. So you can see, for example, for the UK, that they are performing worse for climate action and responsible consumption and production. So this is, climate action is mostly about CO2 emissions and other indicators that are related to that. So of course, high income countries are bigger polluters than lower income countries, so they score badly in this SDG. Responsible consumption and production is about the material consumption that a certain country has. So we see that these are major problems for the United Kingdom. If we look at Argentina, we see that they have other problems. They have peace, justice, and institutions, life on land, so think about biodiversity and so on, reduced inequalities, innovation, infrastructure, and industry, growth, and so on. If you look at Tanzania, it's even more spikier. It has even bigger problems. So, and these are different problems. So, for example, no poverty, zero hunger, health and well-being, quality education. These problems are not issues neither in the United Kingdom or Argentina, but it seems that Tanzania is scoring worse in these SDGs than the other countries. The interesting aspect is that when we look at research priorities, and I would like to emphasize again that these are research specialization. So it's not about the amount of research that they do, is about how specialized they are in certain SDG related research. They are specialized kind in this problem. Tanzania is specialized in these problems. You may argue that for certain SDGs, you have a certain misalignment. So let's think about affordable and clean energy, that is a problem. And here they are not very specialized in this SDG, but they seem to be broadly, first they seem to be specialized in SDG related to research across, and they seem to be specialized in the major problems. With Argentina, you can argue that there are some differences. So for example, they are highly specialized in zero hunger, and it's not a problem for Argentina. But you can use this kind of graphs and this kind of information to look at these relations. Okay, am I specializing in the major problems of my country? So yeah. And when trying to aggregate again this information in country groups, that it's better to have a general picture of what is happening. We have again countries divided in income groups. The different bars have different colors. We have the different SDGs. And what you find, as expected, is that in the majority of SDGs, lower income countries are performing worse. So they are further away from the frontier in almost all SDGs. This was expected. Lower income countries have bigger problems, namely related to poverty, hunger, health, quality education, and so on. The only SDGs that we found that the thing changes, and I've mentioned it briefly related to the UK, is in SDG 12 and 13. So responsible consumption and production and climate action. So here, high income countries are the biggest polluters. So they are the ones that have a higher challenge, a higher problem related to these SDGs. So one could argue that probably higher income countries should focus on research that helps or contributes or is related to these SDGs more than they actually do. Yeah, so this is the main message for this graph. Of course, we went into detail, and here instead of comparing countries, we are looking at a specific SDG. In this case, is SDG 0 hunger, and our objective here is to try to understand if there is some sort of alignment or misalignment between research priorities and societal challenges. So here in the Y axis, we have research specialization. So 0 means that a country is specialized as much as the world in this specific SDG, 0 hunger. Above means that this country, and each dot is a country, is specialized in this research. On the x-axis, we have the distance to the frontier. So these challenges, these problems. And the one means that a country has a higher problem. So in this case, Yemen is the country that has the biggest challenge related to 0 hunger. And then you have the frontier country. In this case, I think is France, that has no problem. So this is the country that is at the frontier in this SDG. So when plotting this information for all countries, what we can see is that the countries that have major problems related to this SDG, 0 hunger, again, these are targets related to levels of hunger, malnutrition, agricultural productivity, sustainable food production, and so on. So these countries that have major challenges related to the SDGs, their relative specialization, so this is not the amount of research that they do, is how much they are specialized in research related to the SDG, is higher than, for example, of the countries that have smaller problems. So here the colors of the dots also represent income level. We can broadly see that high income countries have smaller problem related to hunger, this was expected, and lower income countries have major problem. But the interesting fact, I think, is that we see a certain degree of alignment. So the countries that have major challenges are also in relative terms producing more research. So this is, we would argue, a case of alignment. So the research priorities are in place, although low income countries produce very little research. Now we look at the case of, we argue, misalignment. So here we have SDG 13, climate action, targets related to CO2 emissions, energy related CO2 emissions, in climate change measures, international policies, and so on. What we see, so the same setting, here we have research specialization, the x-axis we has the problems. We see that the country that is, let's say, contributing more to climate change is Luxembourg. It's a very small country, have a higher CO2 emission per capita patterns, and the country that produces less or contributes less to climate change are lower income countries mostly. But what we see is that lower income countries are actually, the research that they do is very much related to the themes that we find are related to climate action, while countries like Qatar, Kuwait, and others, Saudi Arabia, that contribute a lot to climate change, are not relatively specialized in this type of research. So we would argue that in this case, the SDG 13, there is a case for misalignment. The countries that are creating more problems are not the ones that are doing, in relative terms, more research. So yeah, so this is a way that we can also try to understand these relations. We did this, of course, for all SDGs, all countries, and so on. I'm just giving some examples of that try to illustrate some of the major results. So here the contribution is we try to develop new ways of studying to each country's research priorities aligned to their major SDG areas of challenge using scientific publication data and the indicators of the SDGs. And we argue that these results might help policymakers to understand these relations and bring directionality, I've mentioned in the literature review, directionality to the debate. So how should we set our priorities? What direction for our challenges? Overall, we found that lower income countries seem to be relatively specialized in SDG related research. We think this is because of international research funding patterns. So think about the UK research development funds or Bill and Melinda Gates, or so funders that fund a lot of research in lower income countries. They usually fund research that is related to these broad societal challenges. So it makes sense because these countries have very little financial capacity to invest in their research. It makes sense that international research funders fund research that is SDG related, although as we saw, 90% of the research that is done in the world related to SDGs is done in high income countries and upper middle income countries. So there are two, we argue, broad type of misalignments. So absolute misalignments. The majority of the research that is done in the world is unrelated to SDG related issues. And within the research that is done in SDG related issues, 90% is done in high and upper middle income countries, where the majority of the challenges are smaller. There are these exceptions of responsible consumption, production, climate action, but the majority of SDG challenges are worse in lower income countries. We also argue that there are these relative misalignments in different SDGs. We found some alignments in SDG 2, zero hunger, health and well-being, clean water and sanitation. So this means that countries that have major challenges in these SDGs are actually doing, in relative terms, a lot of research related to these issues. So they are doing, they have their incentives right, let's say it like that. But we also find negative relationships, so misalignments. So for example, in quality education, SDG 4, SDG 10, affordable and clean energy, 12 and 13, as I argued before, the countries that perform worst or are further away from the frontier, have higher challenges in these SDGs, are not the ones that are relatively specialized in these SDGs. So here we could argue that maybe there should be some kind of incentives to change the priorities that are in place, or at least this information help us to think about how research priorities are set in relation to the problems, the societal problems that we have. So yeah, this was it. I know it's a lot of information, so please let me know if there are questions, clarifications, and yeah, and then next I have a small exercise that I would like you to help me with. Yeah.
Okay, thanks. Thank you very much. It's really super interesting. So this is not yet published. Or are you going to publish soon?
So the report where this information is going to be published in November 2021. Some of the chapters in the report, for example, this one, the last one, we intend to publish also as a scientific publication.
Of course.
The literature review, the previous part, it will be in the report, and we also did a blog in our website about it.
Yeah.
That one is not be published as in journals.
It's really super interesting. I have a question which is I mean, a very general question. I wonder if you are also working or plan to work with patents. I mean, doing something like a similar exercise with patents.
Yeah, that was in the plan.
Okay.
That is in the plan. As you know, patents are a bit more complicated because the language. So the language that is SDG related in publications, you can find a certain degree of relation. When you find policy language related to SDG in patents, this doesn't work very well. So our strategy there was, and it's still ongoing work, is okay, we have these clusters of publications that we identify as SDG related. Let's see which patents and which patent classes cite more often a certain cluster of publications. So using this science patent relation, we try to identify patent classes that are more SDG related. So this is our strategy. We are doing some work. We already have some results to present, but as you know very well, patents are a difficult thing because I mean, they are to create monopolies. It's a different. I have some issues with that, but we are doing some work also with that, and we hope to publish in the report.
And have you not tried, or do you think that it doesn't work to use the text of patent? I mean, to do a similar exercise you are doing with, I mean, not classes, but text really in the patent description.
Yeah, that's something we did as a trial. So try to identify SDG related text in patents. We had very few.
Yeah, because probably they use a completely different jargon.
Yeah, we have very few hits. Then we thought also about using some kind of machine learning technique. So imagine that if you know that certain patents are kind of related to clean energy or clean water and sanitation. So you classify them, and then you classify text, and you do some kind of machine learning. But that was complicated, and we would need to tag patents. So it was a huge effort. So we end up using this approach of science innovation patent relations. It's not without
I think would be interested. So any further questions from the floor? Clarification or maybe curiosity, if you have anything else to ask. Too many information.
Yeah, I know this is a
I think it's very rich. Maybe not so easy for everybody to follow, but I really learn a lot.
Yeah. So I know it's a lot of information. So as I said in the beginning, my objective was a bit to discuss the literature surrounding STE and SDG relations, and try to give a practical example of a possible way to try to empirically try to understand those relations. I know it's still a tentative. So, but I think it's interesting to show that it's possible to do something with the data that we have available, and it also for the students, it might give them ideas about potential ways they could do for the thesis, for if they want to follow academic career, interesting research patterns. So yeah, I hope.
Yeah, in fact, there is a practical question from Julia. She's asking, how much time do you spend to collect all this information?
That's a good question. So yeah, this project started in beginning of 2020. So there are different work packages. So I've been working on also different things, but yeah, this takes time. So for example, to combine all SDG indicators, I would say you need like a month to make sure that all data is available. And then there are several iterations. For publication data, we had to work, or we are working with CWTS, because also they have access to the entire data set of Web of Science data. So it's easier to use this data, because if you needed to collect all Web of Science data, it's impossible. It's very difficult to take a huge amount of time. but yeah, this takes time. But I think if you are interested more in a specific SDG, you can look at the indicators. You can do certain things that take less time.
Yeah, in fact, I was thinking that for a thesis, for a master thesis, maybe to concentrate on 1 or 2 SDGs could be a good way forward to make an interesting contribution. There is another question from Cinzia. She's asking, how could skilled workforce contribute to reducing inequalities among countries and achieving SDG on equality?
Yeah, that's a broad question that also relates to economic development. But then, I mean, I think the answer here is, of course, that a skilled workforce, so people that have more capabilities and are able to work more productively, also related with sectors that should be more productive. But if people have higher skills, they will, in theory, contribute to some kind of economic development. That these, on one hand, might go well for the entire population and improve the wealth of the entire population. So usually said that it's very important to have skilled population for economic growth. But now it is argued that specific competencies or specific countries are actually, the specific skills are not necessary for future work, and there are only certain types of skills that will be necessary. Think about programming or computer science, that will be more necessary in the future. And actually these skilled people might actually have huge salaries, and the remaining population that don't have these skills have lower salaries. So actually having more skilled workforce can actually contribute to increase inequality. I think this is a very complex question, but of course and related to the SDGs, of course you would always want a more skilled workforce.
Thanks. So I don't know. I mean, how long does it take, the exercise you would like to propose us?
So what we ask in the survey. So basically, this is a survey.
Yeah.
There is this link here.
Yeah.
This is a survey. We say that it takes 15 minutes.
Okay.
So the process of this survey is to ask first your background. Some questions about your background, and then you will choose what is the sustainable development goal that you have more knowledge about.
Right.
And then we will ask you what STI areas, what science, technology, innovation areas you think would be more important to achieve a certain target or a certain objective related to SDG. So we are asking is to different people, so experts, policymakers, in this case students, and so on, and we want to see how different perspectives are according to their characteristics. And yeah, this is basically a collective effort to try to understand perspectives of people related to this. This is a first phase, so I will ask you I would ask you to fill the survey, and maybe some things are kind of empty. If you have any question, I will be here. But yes, it's just try to understand your contribution, or how you see these relations, and then in the end, I would like to have a bit of feedback to know what you think, if you find the exercise difficult, why, and so on. So yeah, if you are okay, it takes 15 minutes. The class is until 5, right?
Yes, because you are 1 hour. Is until 6? Yes. Yeah.
Yeah, it's 20 minutes you will end. So yeah, I would like to, if you can, to do this exercise. Also, it's a nice experiment.
Yeah. Okay.
So you basically have to type this link
Mm-hmm.
If you
Okay.
can.
No, we cannot copy, but we can.
I can put you
in the chat, maybe.
in the
Yes.
chat, so yeah. So yeah, if you click here,
Yeah. Okay.
it should take you to.
Yeah. No. Sorry. No, because it is opening something like it's not this one. It is, I mean, I reached a website which is not this, not the one of the survey.
Okay, sorry. Yeah,
is a website for building a website.
So something went wrong. I'll try to post another link very soon.
Maybe
Where
in
is
the
it?
meantime.